My name is Erno Venäläinen and I come from Finland, where I work for a company called Oracle. I guess most of you have heard of it. Hands up who hasn't. Good. So my role there is as a cloud architect in the Finnish solution engineering team. And what a solution engineer does, we had a couple of nights ago the DevOps BOF, where we talked about the kind of roles that you have in the IT. And usually there are lots of generalists, there are few specialists, but nowadays what all the companies are interested in hiring are these cross-functional specialists. But then there's also what I call a deep generalist, this comp-shaped professional, where the solution engineering comes in. So what we do is customer demos and interact with the sales, and we need to have a breadth of understanding about the topic and some depth to it. Although at the end, you know, we need to ask the experts for some really special information. And at this point, I want to define what hacking means. So it's to come up with creative solutions to technical problems. So in this context, and I think in general also, it doesn't mean anything illegal. Although, you know, with these tools and technologies that you can use to hack your vehicle, you can do illegal things. For example, if you want to change the vehicle odometer setting to get a better price for your car, don't do that. Or if you want to, for example, on some of the high-end premium cars, there's this brake disc wiping, which can be controlled from the CAN bus. So when it rains, it applies just a little bit of pressure on the calipers, so it keeps the calipers dry. So if you want to implement that, for example, on your motorcycle, it can have very negative impact on your life expectancy. But so this, well, as a daytime job, I work as a solution engineer, but this started as a hobby project. I have a lot of hobbies. I like practical things. I love building Legos. These are not my Legos. I'm not that rich. This is from a Lego building expo, which is organized every year in Finland, where I go with my kids. I like practical carpentry, like building our house. I'm never going to do it again. Some really geeky stuff like painting Warhammer miniatures. Any Warhammer gamers here? A couple? Yeah, excellent. I'm still waiting for my kids to grow up so I have someone to play with. Then I also enjoy practical electronics. This is my 3-node Raspberry Pi Kubernetes cluster. And my colleagues at work ask me what does it do? Well, it clusters. But isn't it awesome? Yeah. But yeah, so what I'm going to talk about here is my hobby about motorcycles, and I'm part of our local club. I'm a member of the board there. We have some like 600 members there. That involves like daily stuff running the club and also organizing races. I was part of the World Championship timekeeping team for the Finnish GP in the Enduro World Championship event, but as it happens, the Finnish GP got cancelled at very late stage for the next year, so it was arranged 2 times. But I leave the racing for those who can really do it and have the guts. So what I have, this is my Triumph Speed Triple model year 2009. So it has this, I like it. I used to have a Aprilia V-twin bike, but I always wanted the Speed Triple because I really like the kind of bug-eyed, iconic design. This kind of factory Street Fighter style. So it has a 3-cylinder engine, and I think there's something very kind of melancholic in the 3-cylinder engine sound It's like it's crying after that one lost cylinder. And as said, it's modestly modified, so all it has is it's been remapped, and it has this 3-to-1 DIYhard audiovisual system, so which pops and spits fireballs, and it has a custom paint job, so it wasn't intentionally painted in the company colors. I bought it before I joined Oracle, and anyway, it was painted like that when I bought it, because, you know, I wanted the speed triple, but I didn't want to spend too much money on it, so I found this bike which was crashed, and by the mark it was crashed at least 2 times. But the guy who fixed it, he does that for his living, noticed that it didn't have any bad marks on the body or anywhere. It's just needed a paint job and some cleaning up. So he bought it from the insurance company and fixed it, and it, you know, I've had this for 3 years and it's running fine. So I always wanted to have a bike which I can run, but then, you know, because I like more hobbies, I wanted to get a project bike, and I was looking, because I was missing also the V-twin, or let's say performance V-twins. There are other kinds of V-twins which aren't so fast. I was looking for a Ducati, and this is a Ducati 999R. I don't have this bike. I don't like it. I don't think the design is very special, but, you know, it has an amazing engine, and what's special is that it has this kind of add-on trellis frame on the back, so it's really easy to clean up and build as a street fighter. So because it wasn't very popular, because the previous bike was this again iconic Ducati 998, and what followed it was this Ducati 1098. But, you know, obviously with this one something went very wrong with the design. So I don't know, the headlight looks like some science fiction prop, and the tail light looks like something that's, when it came out of the factory, the guys realized that, ooh, we forgot something, and just fixed something on it. And the mirrors are pretty useless. You can only see your own elbows in them. But it's a good starting point, and what I would like to do is build it like this. This isn't my bike. This is a bike done by a Rocket Garage, which is an Italian cafe racer shop. This bike is called Atresso Veloce. I don't know how to spell that. But as you see, if you just strip the dorky fairings and put some additional note in it, it's really easy to build into a very nice bike. And what kind of prompted me for this hacking project, apart from what I was already doing for my speed triple, was the fact that, you know, it has a backpack full of all kind of electronics and this instrument panel which is the size of a brick. So it's really difficult to fit onto a cafe racer. But according to the Finnish law, you need to have some instruments on it where you can, for example, see the speed on the bike. And it's always good to have those engine indicator lights if something goes wrong, because it's, you know, it can hurt. Not just your wallet. So why? Really just out of curiosity whether I could hack my motorcycle, what could be done. And it's also very good practical application for physical computing exercise. Part of my job is also to kind of build the IoT demo cases for my employer. And, you know, not just blinking the LEDs. If anyone has built Arduinos or Raspberry Pis, all of the kind of tutorials, they just blink the LEDs, but that's not very exciting in the long run. So it's really interesting to find some practical applications. So where it started is that I had, for my Triumph, bought this IoT platform for PyCom because, first of all, it runs MicroPython, and I wanted to learn to program Python better. It's multi-threaded. It has this additional shield with the GPS and accelerometer, and also a lithium polymer battery charger. And what's most interesting, it has a quadruple network support. So what really makes up the IoT and what's making it more popular nowadays is the network applications which are available. So earlier on we had Wi-Fi and Bluetooth and cellular networks, but all of those consumed a lot of energy. So in recent years, LoRa and Sigfox have become more common. And with this PyCom, you could get 1 year, also 1 year subscription for Sigfox enabled. Who knows what LoRa and Sigfox are? Couple of hands, good. But let's recap a little bit. So if we look at the networking technologies and we put range on one axis and bandwidth on one axis, and if we look at, for example, Wi-Fi, so it has a quite wide bandwidth, but the range isn't that good, and it's going to be very power consumptive. And then we have the mobile internet, which also has a range of few hundred meters to a couple of kilometers in the rural area. And also that, as you can often see how hot your phone gets, it also uses a lot of energy to connect, and that's why you need multiple antennas, for example, in cities to enable the connectivity. And then there's Bluetooth. So at some point I didn't believe that I'm ever gonna live to see a working Bluetooth application, but you know, in the recent years it has been much more reliable. So Bluetooth, again, it has a limited range, it has a limited bandwidth, it doesn't consume that much energy, but you cannot really reach that far, only a couple of meters range from where you are. So we needed to invent something else, and that's where LoRa and Sigfox come into play. So it has a very narrow bandwidth, meaning that you can send only a limited amount of data, but it has a huge range, and also the energy consumption is very low. So what it stands for is the Low Power Wide Area Network, LPWAN. And for LoRa, for example, you have this Things Network connectivity, where anyone who wants to join the Things Network can put up a cell and provide the LoRa connectivity for other users. And Sigfox, it's a French company, they have their own network where you can buy these subscriptions. Of course, for LoRa also there are kind of national providers, but they're not that common yet. But Sigfox is usually that it's easy to buy and it's easy to start using it. So what I had is that I wanted to, how this project came about is that I wanted to have on my bike some kind of a alarm system. So if someone would take the bike and move it, because the PyCom module has also a GPS and acceleration sensor. So if it moves, it wakes up and starts sending the connectivity information over Sigfox network to the Oracle cloud. But that wasn't enough, so I wanted to experience some more. And then one day reading Make magazine, I saw this advertisement or a short story about the Macchina M2, which rhymes nicely with Macchina Ducati. So it's an open source automotive development board. It's completely open source, so you get the schematics, and if you want to extend it, you're free to use it. And it's based on Arduino Due, so you have the same programming experience as with Arduino. and you can use the same tooling. You just add it as a different board into your Arduino workbench. It has under the hood and under the dash versions. So under the dash version features the OBDII port, which you can use directly to connect into your car. And what's so special about this Macchina is that it has all of these automotive interfaces embedded into it. For example, with the Pico model, it has a CAN support, but it doesn't have the CAN transceiver because you need some transceiver to decrypt the CAN messages. But this Macchina board supports many automotive interfaces by default. So there's the CAN, which is the controller area network, single wire CAN, which is a more limited version of it, LIN, which is a local interconnect network, which is for less important parts of the communication. Then K-line, which is an older standard, for example, which is found on the Triumph that I have. And then there's the J1850, again, which is one of the more limited controls. So, to get this connected, most of the cars, at least manufactured after 2003, have the OBDII board port, which is the onboard diagnostics port. And the OBDII standard specifies the type of connector, and it's pin out and these electrical signaling protocols available, and the messaging format, so how the message is formatted when transmitted through the network. And how the OBDII standard, even its original form, I think it was invented something like 1996, that early. It was prompted for the diagnosis of the emissions equipment. So, for example, in Finland, we need to provide, when we go to check our car every 2 years or every year, we need to have this a statement for the emissions, and that can be read from the OBDII port. And also, because it's a practical way to access the car and do the diagnostics, the manufacturers add their own custom data parameters to their specific OBDII implementation. For example, that one can get those real-time data requests and double diagnostics trouble codes. So if you buy one of these USB dongles which you can connect to your phone, there's a set of very common OBDII messages which you can use to get the data out of the car to your phone. That's how it works. So any ODP compliant vehicle can use any of the 5 communication protocols. The CAN bus is the most common, mandatory for all 2008 plus vehicles. Then the ISO 14230 is a very common protocol for earlier vehicles, like my bike. And then there's also this older protocol, ISO 1941. And then SAE diagnostics, which are mostly used on US General Motors manufactured devices. And if you look at the ODP port under your car, you can tell from the pin out that which protocols it uses. If you don't have the OBDII port, then you need to have some kind of, for example, logical analyzer or other meter to kind of detect that what kind of protocols and standard it uses to communicate with any diagnosis tools. And also, these are just the standard pins, but if you look at the OBDII connector, there are multiple pins, so the manufacturers can add additional pins for their own diagnosis. But usually these are closed, so you cannot always tell that what they do. Of course, it's not in the interest of the manufacturer to share all the data, because they don't want people to start tinkering with those, but for some manufacturers, the data is available online. It really depends on your car manufacturer, what's available. And if you are a developer, you can also buy the standards, but they cost from 1,000 euros to close to 10,000 euros, and then you need to also pay this yearly subscription fee to get the updates to these standards. But you know, as a hobbyist, it's really not feasible to do that. So what can you actually find from the OBDII and the CAN bus? There's lots of data available. It really depends on what the car manufacturer wants to provide. So what's usually available from the OBDII board with those plug-and-play USB dongles is the engine control unit data, ECU data, like engine RPM, throttle position, intake air temperature, manifold pressure, coolant temperature, and the MIL business malfunction indicator lamp. So if something goes wrong, you can get the data to display this indication that you should go and check your car, and also the DTC, the trouble codes. And you know, also those are encrypted, or the format of the trouble codes is manufacturer specific. So you need to have some kind of a workshop manual to get the information what's over there. And that information on the left is usually available from the OBDII port, but then there's also lots of other information which you can get from your vehicle, and also some features. You know, when you buy a car, and you only pay for certain luxury items, most of them could be available already in a car, but it's just disabled by software. For example, some motorcycles have the same engine and same transmission, but they don't, for example, show the selected gear information available. So if you can plug into your car or motorcycle, you can find whether you can get the selected gear information by just listening onto the CAN bus. So even to make this even more complicated, there are also lots of other CAN standards and new standards, because of course the breadth of messaging that happens in the new cars, you cannot just keep up with it. So kind of car manufacturers are coming up with new standards, and what is nice is that they are kind of converging on the standardization, so it would be easier to for developers or smaller shops to get into the industry and see what they're doing. And there's also a project called Open Vehicle Linux, so they are developing an open operating system for the cars. So in essence, what CAN bus is, it is just, you know, two wires ended by resistors, usually twisted pair, and it's a masterless system. So any node on the bus can transmit, but they need to listen and wait for the transmission turn. And if they transmit at the same time, there's this mechanism which checks for the importance of the message, so that the lesser important messages get kind of terminated, and it allows for the important messages to go through. And what then single node is, it has this microcontroller, for example Arduino or this PyCom, and then it has the controller side of it, and also the transceiver which decrypts and encrypts the CAN information data. And I said that it's not that easy to get the data out of the vehicle, because you need to know the standards and the manufacturers don't want to open it. But luckily there are some modern tools for that. So this is one example for CAN bus hacking, SaviCAN. It's an open source CAN bus reverse engineering tool. And what it does is that you plug the savey can into your CAN interface and start listening onto the messages. So in most of the cases, you can find the data from the OBD port, or then you need to connect to somewhere near to the electric control unit of your car. But because all of the data is going through in the CAN bus, you can listen to it. And for example, it's difficult to get get understanding of the data from a running car, but you can start by just having the car put in the key there and see what kind of messages start passing by. So it's possible to kind of find out from the IDs and the data, if you just start logging them, that what it's supposed to do. For example, if you just wait there and put on the turn signal, some of the values start changing, so you can find out, okay, this is for the turn signal. And what they are is these DBC data, and for some cars you can find the DBC data online, so that you can find out immediately that what it's for. There's also interesting project led by George Hotz, who's a hacker from US, and he used to work for Tesla at some point, but now he's building this Open Pilot, which is an open source autonomous pilot for cars. So what is based is you can run the system already on some model of Toyotas, some Hondas, and some GM vehicles. So basically you plug one of these Panda USB interfaces, and then it has your kind of phone-sized computer, which is computer vision enabled, and it plugs into your sensors of the car, and it really works. There are some videos of the application of the autonomous car driving, of course, on some limited roads in the US, like this in the case of Waymo, for example. But you know, it's interesting that there's open source applications for it. But it only works for a limited amount of cars, because most manufacturers don't publish the data that you need to control, for example, the transmission and the engine and turn the driving wheel. But you know, this is really the beef of hacking your system, and it's amazing what kind of data you can find, and it's really rewarding, or it can be boring or frustrating, because at some point, you know, I think most people know this comic that, well, it works, why? It doesn't work, why? That's the problem with the reverse engineering, because there's no spec. It would be nice if everything was open source, that you could find the details and the data readily available. But okay, back to my own project. So earlier on I had the PyCon, which provided me for the connectivity, and now that, you know, I could connect, I added the Macchina system there, which connects to my bike, and you know, when I started up, I get the information that, okay, the bike is running, so probably it's me who's using it. So I can kind of the system can quit to send the location and GPS data over Sigfox to the cloud, and now that it knows that it's running, it can use the bike power and connect to my phone's Wi-Fi system to start posting all of the bike onboard diagnostics data into the cloud via the Wi-Fi. So for example, what's available from Triumph is intake air temperature sensor, manifold pressure, lambda sensor, which is kind of the environmental sensor there, coolant temperature sensor, barometric pressure, side stand width, road speed sensor. All this data can be found via the OBDII port, even without doing any actual hacking. But like, my original problem was to have some kind of user interface for the car, to have a special dash for it because I want to get rid of any big instrument panels because it looks so much cooler. I started experimenting with LCDs, for example, but you know, it's not that elegant. And then there are OLED displays, but if you try doing programming these OLED displays, drawing the vectors and filling them, you know, it can get quite complicated. But after some searching, I found out that there's the company called 4D Systems, which provide this intelligent display units in quite many formats. So it's also possible to get this kind of round, small display, and it has its own processor, so it can offload the processing from the microcontroller that I'm using from the Macchina, which is based on Arduino, and it's compatible with multiple applications, so Arduino and also Raspberry Pi, and it can be used for some other robotics projects also. And it's used, programmed using the 4D Systems workshop for IDE software. So it's really what you see is what you get, graphical display where you design your UI and then you just assign these actions and then it creates some of the code stubs for your Arduino. So it's really easy to hook up with your system. And all of the media files for the displays and the graphical items, you can also build your own graphical items using the wizards there. You don't need to use the existing, but you can draw your own. All those media are loaded onto SD card just to, again, to offload the storage from the microcontrollers, which don't have that much storage by themselves, to build these visual applications. So, in the end, it was quite nice. I was myself pleased, so I had all of the details that I need to build for my system over there. I get the vehicle data via the Macchina, I get the connectivity from the PyCom, and then I have the user interface or the dashboard using the 4D Systems LCDs. So what's next then? To take this project even further, I would like to build some kind of heads-up display. I was a little bit amazed that there aren't that many commercially available helmets, for example. If thinking of added reality systems, because you have the helmet, you have this gadget already on your head, which provides space for power and computing systems, and you have the visor which could act as a heads-up display, but it turns out that there aren't many systems. Of course, the AMOLED technology is still its infancy, which can be used to kind of reflect the data on behind your lenses, but you know, it's estimated that by 2020 it gets much more common, so I'm really looking forward to what kind of applications you can get. But already you can buy these. For example, there's a company called Devoxx who manufactures, I think they released it generally available just a week ago, these very small sized Android based AR glasses for which you can start building your applications, and because it's based on Android, it's quite familiar working bench for a lot of developers. And then about assistive controls, there's the image on the top right hand corner is the LiDAR. So lots of cars have these warning signs that, for example, if someone is too close behind you or that if you're going to hit someone, those are based on LiDAR systems, and it would be interesting to implement also those for motorcycles, just to see what you can build with them and display the data with your heads-up display. And voice controls, you know, motorcycle gearbox it's a stacked, so it doesn't have this kind of map that which you can have to track the gear change like in cars. Instead, you just pull the lever up when you want to change gears to higher gear, and down when you want to change lower. Of course, you can also reverse that map, but it's up, 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 or down, down, down. So it would be interesting to build this, for example, voice-controlled gearbox for your system. I think I need to buy some cheap Yamaha if something goes wrong. But then there's also motorsports applications. I did a lot of work with the Finnish road racing teams, let's say 10 years ago, before the kids came along and we started building the house when I had more time. So I'm still, cooperating with some of the teams, and I started collaborating with Kulju racing team. So what's special about this is that the team rider Ulla Kulju, she's paralyzed from waist down, and she's the World Championship of Parathletic motorcycle racing for 2017. And in order for her to drive, there are some special setups. So, for example, there's this button controls for the gearbox, and also the handbrake for the rear brake. You just have to have it, but if you're racing, you really don't use the rear brake. And another special application is what's on the lower right hand corner is the saddle, because she needs to be kind of put into place on the bike, because she can use her lower body. The saddle has this special application or system which is printed by 3D, and it moves according to banking. But that's still a prototype, so we are investigating what could be done to make it more progressive. For example, to use the acceleration sensors in the PyCom and also the GPS to map out the track, and when you need to kind of brake hard or accelerate hard, it would have some kind of servo motor, which then makes the construction more stiffer, so it won't move that much. And also another application for this is that actually her racing year this year was ruined because she fell and broke her leg and some other bones in a race in Finland, so she couldn't participate in the World Championships this year. And that was caused because when you are racing, you kind of feel the track with your knee, but because she can move them, she doesn't know that how steep is the bike's angle. So that's why you can actually see that why she fell was that one of the foot pegs touched the asphalt because she was going too steep, and then the bike went down. But the application that we're looking to build for this is to again use the PyCom with its acceleration sensor. So it would have an LED that when you're banking, it would display a yellow light, and when you're banking too hard, it would display red light, so you know that you have to kind of fix your position. All right. And really going forward from here, kind of the takeaways from this project is, for me, how easy it is to build these physical applications, build the IoT systems. And if you want to yourself look into this, I would recommend this book. It was published by Electra magazine. It gives quite good examples on what you can do with it. And there's also the O'Reilly booth downstairs, which features these physical computing projects on Arduino. That's a good starting point. I can also recommend that book down there. And when on my winter vacation, I'll try to find some time to put all this work onto GitHub and publish it, so it would be available for anyone else to also use. I've been just too busy doing the project and at work, but I'll make everything available so other people can try it out. Now we have some 10 minutes for questions. Yes, please.
What data does your display actually show on your motorcycle now?
It shows the RPM of the system and the engine, the kind of bike speed, and also the fault indicator lamp and the kind of free gear indicator. So when it's on this free gear, that's enough for me at the moment. Of course, I'm looking to inject more data, for example, displaying the vehicle fault codes and all things like that. Something else? Okay, thank you.